Okay, this is chapter 7.1, angles of polynomials. So we're done with triangles for now. They are a polynomial, but now we're going on to sides that are more than three. So four-sided figures, a quadrilateral, five-sided is a pentagon, six-sided hexagon, and so on. So what essential question is, what is the sum of the measures of the interior angles of a polygon? What you will learn is use the interior angle measures of polygons and use the exterior angle measures of polygons. So let's take a look at this. Okay, theorem 7.1, polygon interior angles theorem. The sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. So the book really doesn't explain this very well. So let me try to explain it to you. So let's start off with something we already know, and that is a triangle. So you have a triangle, and it has three angles. This n is the number of sides, n-gon, okay? Five-sided figure is called a pentagon, six-sided figure, hexagon, so on. N-gon just means an n number of sides, gon meaning side, polygon, many sides. Okay, so in a triangle where you have 1, 2, and 3 angles, there's 3. So you would take that n minus 2 times 180, and that equals the sum of the interior angles. Well, how many sides or how many angles are there in a triangle? Well, there's 3. So you've put 3 in for n, and you get 3 minus 2 times 180, which is 1 times 180, which is 180 degrees. Okay, so then if I went to a square or a rectangle, and there's 1, 2, 3, 4 angles, then it'd be n minus 2 times 180 equals, and our n now is 4 minus 2 times 180 equals, and 2 times 180 equals, because 4 minus 2 is 2, and 2 times 180 is 360 degrees. So in a rectangle or a square, 4 90-degree angles add up to 360. So this works. So it works for any value, but I started with n being a three-sided figure, a triangle, because we've just worked with those, and we've worked with squares and rectangles. So it's true for all. All right, so now let's take a look at this theorem. So it says the measure of angle 1 plus the measure of angle 2 all the way up to the last angle. N number of angles is n minus 2 times 180, which I just explained. Here is a six-sided figure. 6 minus 2 is 4. 180 times 4 is 720 degrees. So these six angles would add up to 720 degrees, for example. So we're going to use this theorem in the next examples. All right, so here's example 1, finding the sum of angle measures in a polygon. Find the sum of the measures of the interior angles of the figure. So the first thing I'm going to do is number them. I'm going to start top left. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 angles. So I write the formula n minus 2 times 180. Okay, and my n is 8. So then I simplify 8 minus 2 times 180. And simplify some more. 8 minus 2 is 6 times 180. And 6 times 8 is 0. 6 times 8 is 48. Carry the 4. 6 times 1 is 6. Plus 4 is 10. So there is a sum of 1080 degrees. Okay. And that's how you determine the sum of the angle measures of a polygon. So now you should be able to do problem numbers 3 and 4 in the exercises. Okay, so here's example 2, finding the number of sides of a polygon again. The sum of the measures of the interior angles of a convex polygon, I'm going to highlight that, is 900 degrees. Classify the polygon by the number of sides. Okay, convex. Let's talk about the words first. So let's do a convex quadrilateral, four-sided figure. So if I go out like this and out like that and out like that, like so, actually, let's go five-sided figure. Let's do a pentagon. So here's a pentagon. Okay, any five-sided figure. If this angle and that angle and that angle and that angle and that angle are all opening up so that, how can I explain this? Well, let me explain it this way. I'll show you if what would make it concave. So if I take this convex polygon and then go in like this and back like that, so now that's acute and it was obtuse, and now this angle is greater than 180 degrees. That is a concave because it got caved in. So a convex polygon is where if you extend any one of the sides, it will not go through the interior. So once I made this concave, as you can see, if I extended these sides to infinity, right here, it goes through the interior of this polygon. That is concave. So let me go back to my convex polygon that I had right here. Extend this side, you're never going inside. Extend this side, you're never going into the interior. Same with this one, same with this one, and same with this. You never go to the inside. Every side extended will continue outside of the polygon. That is the definition of a convex polygon. Okay, so now that we know what convex means, we have a polygon, many-sided figure that's convex, 900 degrees total interior angles. How many sides does it have? That's what this question's asking. So you do n minus 2 times 180 equals 900 degrees. Okay, so you write the formula, you substitute the givens, and you simplify and solve. To get n minus 2 by itself, I'm going to divide by 180 both sides. Okay, these cancel, and I'm going to get n minus 2 equals, and 90 divided by 18 is 5. Okay, and I add 2 to both sides, and I find out n, which is the number of sides. So this is a 7-sided polygon if the sum of the interior angles is 900 degrees. Okay, so that's how you do example 2, and now you should be able to do problem 7 and 8 in the exercises. All right, corollary 7.1. Corollary to the polygon interior angles theorem, the sum of the measures of the interior angles of a quadrilateral is 360 degrees. So I've already explained that to you with the rectangle or the square and that previous theorem. And what was that theorem called? Theorem 7.1, polygon interior angle theorem. And so a corollary to that, once you know a theorem and you can obviously state something, that's what a corollary is from the theorem. A corollary to the polygon interior angle theorem just says that the sum of the measures of the interior angles of a 4-sided figure, a quadrilateral, is 360 degrees. Okay, so let's get that out of the way and take a look at problem number 3. And it says to find an unknown interior angle measure, find the value of x in the diagram. All right, so you want to write a formula. Okay, it is a 4-sided figure, but we just use the corollary and know that there's 360 degrees in a quadrilateral. So what you would do is say 108 degrees plus 121 degrees plus 59 degrees plus x degrees equals 360 degrees. Okay, no more arithmetic. Write a formula. Okay, it's a quadrilateral sum theorem according to that corollary, and solve for our unknown variable. And so you write a formula, you simplify after substituting the givens. Okay, so actually what I should write is measure of angle 1 plus a measure of angle 2 plus a measure of angle 3 plus a measure of angle 4 equals 360 degrees. Substitute in 8 and 1 is 9 and 9 is 18. Carry a 1, 5, 6, 7, 8 plus 0 is 8. And a 1 and a 2, and it's 288 degrees plus x equals 360 degrees. Subtract 288 from both sides. And we are going to be left with x equals 6 to 5, borrow, and we get 10 minus 8 is 2. 3 minus 1 is 2, and add 10 to this. 15 minus 8 is 7, and the measure of this angle is 72 degrees. Okay, so that is how you use the corollary to answer these questions. So now you should be able to do problem numbers 11 and 12 on your exercises. Okay, so example 4 says finding the angle measures in polygons. A home plate for a baseball field is shown. This is the home plate. Is the polygon regular? Explain your reasoning. Well, we haven't discussed any of the vocabulary, so I'm going to do that now. Is the polygon regular? A regular polygon is a polygon whose all their sides are congruent and all the angles are congruent. Since I have an obtuse angle here and a right angle here, that's all I need to prove that this is not regular. Is the polygon regular? A, no, comma, angle measures are not congruent. Angle measures are not congruent. Okay, I have an obtuse, I have a right, they're not congruent. I want all my angles congruent in order for the polygon to be regular. It asks me to find the measures of C and E. Okay, well, there's something we need to do here. We need to determine how many degrees are in a polygon with 5 sides. So the first thing I'm going to do is say n minus 2 times 180 equals. And then I'm going to substitute in for my n. So there's 1, 2, 3, 4, 5 angles. So that's 5 minus 2 times 180. And that's going to equal 3 times 180. And that's going to equal 3 times 0, 0. 8 times 3 is 24. Carry the 2. 3 times 1 is 3 plus 2 is 5. So I know this has 540 degrees. I'm going to show all my work. So I'm going to say the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D plus the measure of angle E equals 540 degrees. Okay, that's what we found a 5-sided figure to have a sum of. And the measure of angle A is 90 degrees. So I wrote a formula. I'm now substituting my givens. Angle A is 90. Angle B is 90. The measure of angle C, I don't know. Plus the measure of angle D is 90. Plus the measure of angle E equals 540 degrees. So I have 1, 2, 3 90-degree angles. 9 times 3 is 27. So 90 times 3 is 270. So the measure of angle C plus the measure of angle E plus 270 degrees equals 540 degrees. Subtract 270 degrees from both sides. And I'm going to get the measure of angle C plus the measure of angle E equals 270 degrees. Okay, because 540 minus 270 is 540. And now notice there's one arc here and one arc here. That means they're congruent. So let's just call them X now. So call this X, and since they're congruent, X plus X equals 270 degrees. 2X equals 270 degrees. Divide by 2, and we find out what they each are equal to. So X equals 1. 2 goes into 7 3 times. 2 goes into 10 5. So the measure of angle E equals the measure of angle C equals 135 degrees. And that is the answer to part B. Okay, so now that I've done that, you should be able to do problem numbers 19 and 20 in your exercises. Okay, so we have another theorem, 7.2. Polygon exterior angle theorem says that the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So what you do is you extend the same direction. So think of something spinning like a saw blade, and you're not going to extend one this way and then one this way so that they meet. You're going to go the clockwise or counterclockwise, depending on which way you want to go. And you make an exterior angle at every single vertex. When you do that, your exterior angle, angle 1, plus angle 2, plus angle 3, plus angle 4, plus angle 5 in this diagram is going to add up to 360 degrees. So to find one, if it is a regular polygon, you just divide by the number of angles or sides. Okay, so where does this come from? Well, if I had a polygon with 5 sides, what's the sum of its interior? N minus 2 times 180. This has 5, so it'd be 5 minus 2 times 180, which is 3 times 180. And that's 0, 4, 5, 540 degrees. Well, if I break 540 degrees up evenly 5 ways, 5 goes into 5 once, 5 will not go into 4, 5 goes into 48 times. So I have 108 degrees. So let's pretend this is a regular polygon. This would be 108 degrees. And then when we look at the exterior, 360 degrees divided by 5 is 5 goes into 36 7 times, 5 goes with a remainder of 1, 5 goes into 10 twice. So I have 72 degrees. So if this is 72 degrees, well, what is 108 plus 72? Well, drum roll, please. It's 180 degrees. So if this were a regular polygon, the interior angle plus the exterior angle, since that's a straight line, must equal 180. I assume this is regular, even though it's not. But if this were a regular pentagon, then this is how we would find one angle. Find the sum of the angles and divide by the number of sides. Find the sum of the interior and divide by the number of sides. And those two numbers should be supplementary. Okay, so that is the polygon exterior angle theorem explained. Okay, find the unknown exterior angle measures. Example 5, find the value of x in the diagram. So there's a 2x here, there's an x here, there's a 67 degrees here, 89 degrees here. The first thing I want to look at is, can I draw a line through the interior if I extend a side? And that's no, and that is no, and that is no, and that is no. So if I extend any sides, I do not get through the interior. So this is convex, okay? With a convex polygon, the sum of the interior angles is always 360 degrees. I don't care if it's got 100 sides. The sum of the exterior angles is 180 degrees. So I'm setting up my equation. I would say 2x degrees plus x degrees plus 67 degrees plus 89 degrees equals 360 degrees. 2x plus x is 3x degrees. And combining these two, 9 and 7 is 16. Carry the 1. 8 plus 6 is 14, plus 1 is 15. So I have 3x plus 156 equals 360. Subtract 156 from both sides. Remember, we're trying to solve for x. We're isolating the variable, just like we did a million times in Algebra 1. These cancel. We get 3x degrees equals, I'm going to have to borrow here, 10 minus 6 is 4. 5 minus 5 is 0. 3 minus 1 is 2. So I've got 204 degrees. I'm going to divide both sides by 3. And I'm going to get x equals 3 goes into 26 times with a remainder of 2. 3 goes into 24 8 times. So x is 68 degrees. Find the value of x in the diagram. It is 68 degrees. Always check to see if you answered the question. And you should always check as well. So if this is 68 degrees and this is 2x or 2 times 68, 68 times 2, 8 times 2 is 16, carry the 1, 6 times 2 is 12, plus that carried 1 is 136. And I get my calculator out and check, because that's what calculators are for. 136 plus 68 plus 67 plus 89 has to equal 360. And sure enough, there it is. So that is how you answer a question like this with exterior angles. Now you should be able to do problem numbers 23 and 24 in your exercises. Okay, example 6, finding angle measures in regular polygons. Okay, so the trampoline here shown is a shape like a regular dodecagon. Regular meaning all the sides are the same length and all the angles are the same measure. Dodecagon means a 12-sided figure. Okay, so n equals 12. Okay, you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there are 12 sides, so n equals 12. That's a dodecagon. A, find the measure of each interior angle. Okay, so to do that, you take the interior angle theorem, n minus 2 times 180 equals, and then I substitute 12 minus 2. Actually, I don't want to show it like that. I'd prefer to just do vertical. Okay, there's the formula. Substitute the givens. 12 minus 2 times 180 degrees. And that is 10 times 180 degrees. And that is 1,080. 1,800, I mean. 10 times 180 is 180 with a 0 at the end. Okay, that is the sum of the interior. It says to find the measure of each. Okay, so I'm going to make an adjustment to this. You don't have to erase it if you copied that, but watch what I'm going to do here. If it says find the measure of the sum, this is the formula. But if it says find the measure of each interior angle when they're regular, then you then divide by how many there are, which is n. Okay, so let's redo this. So it's 12-sided figure minus 2 times 180 degrees. Didn't want that other parenthesis, hang on. 180 degrees divided by 12. 12 minus 2 is 10 times 180 degrees over 12. And that will be 1,800 divided by 12. And just for time sense, I'll do this. 1,800 divided by 12 is 150 degrees. So that's the measure of each interior angle because they add up to 1,800 degrees. Find the measure of each exterior angle. Okay, well, there's 12 sides, so there's 12 angles. And the sum of the exterior angles is always 360 degrees. Okay, so what you're going to do here is you're going to take 360 degrees divided by n. Okay, the number of sides, and that's going to be 360 degrees divided by 12, which equals 15. I'm sorry, 30. 12 goes into 36 3 times with a 0 left over. Okay, so 30 degrees. So the measure of each exterior angle is 30 degrees. And the other way we could have done it is we know it's going to be supplemental to the interior angle. And 150 plus 30 is 180 degrees. So these are the answers to our two problems. This angle inside here is 150 degrees. And if I extended one side or any of the sides, so if this is 150, I want to know what the exterior angle is at that juncture where I extend that side. Let me show it as extending this side right here. So what that means is this angle out here is 30 degrees and this angle here is 150. So hopefully you can see that now like this. 150 degrees plus 30 is a straight line, 180 degrees. Okay, so that's example 6. Now you should be able to do problems numbers 27 and 28 in your exercises. Okay, that brings us to the end of chapter 7.1. So do these problems if you haven't done so already. Thanks for watching and have a great day.